Hey guys, this is video 16.3. We're going to be talking about half-life in this note video. This could be a review for you, depending on what classes you've taken. Maybe in earth science or in some of your math classes, you may have talked about half-life before. We're going to try to keep it pretty straightforward and pretty simple, or as simple as possible. So there's going to be a couple ways I'm going to show you how to do this, but have your reference tables out. Table N is going to be a big help for you, and the rest you can kind of reason out with your mind if you kind of think about what half means. So the nuts and bolts here: radioactive substances decay at a constant rate that is not dependent on any other factors such as temperature, pressure, or concentration. Okay, so let me clean that up a little bit. Up until this point, guys, all the reactions we've talked about have, been temperature dependent or pressure dependent or concentration. Think about like Le Chatelier's principle, right? Here, though, why we save this for the end of the year is that these reactions, these nuclear reactions, whether they're fission or fusion or whatever type of decay maybe, they are kind of separate. These are not ordinary chemical reactions. So, they're not going to be dependent on that stuff that ordinary ones we've talked about are dependent upon. It's impossible to predict when an unstable nucleus will decay because it's completely random. All right, it's a random process. All right, the only thing that can be determined is the number of unstable nuclei that will decay in a given time. Therefore, half-life, or the time it takes for half, hence half-life, right, half the mass to decay of that isotope. Okay, so it's not saying that the sample itself is going to be half as much, but it's those isotopes that we're talking about. Okay, so if you had an isotope that was 50 grams, and it was purely that isotope, then it would break down and it looks like the mass is getting smaller because it's being transformed into something else. It's a very important concept in nuclear chemistry. Half-life varies per substance, so table N is going to be your biggest help and tool for it, okay? So table N doesn't list necessarily all the isotopes, they're just selected ones. Typically go from shortest at the top down to longest, but there are some exceptions in there. And as soon as I say that, you might be pointing out, well, I see seconds right here in the middle. So just make sure, guys, D, is days. Y equals years. S is seconds. H would be hours. It's pretty straightforward, but just so you're aware, MS is the other one, and that equals milliseconds. Okay? So just be aware of those and be able to look for them. Be careful. Make sure I would encourage you guys to, when you're looking for a specific isotope, take your pen or your pencil and actually, make a mark at where it is to make sure it's the correct one. All right? Basically, what you want to take from this is the shorter the half-life, the less stable it is. The longer the half-life, the more stable. Now, stable doesn't necessarily mean dangerous or not dangerous. It just means it's going to break down. So when we talk about stability, it's just how fast it's breaking down. Okay, so less stable means it's breaking down faster, and more stable means it's going to last longer. Let's jump in and do some practice problems here. We're going to kind of work through these examples together. If you want to pause the video at any time and try to do it yourself, I encourage that. And again, ask questions as we go along. So you can think about it, and again, this might be for math class, depending on what math you're in. You may have talked about some math formulas. So these are the formulas listed here, guys, but I try to, with all my students every year, just try to have them reason out what a half-life is and kind of think through it just practically versus trying to memorize another formula. These are something that, if you think about the term half, where you divide by 2 or multiply by 2, you can kind of reason it out without trying to memorize extra information. So use that space in your brain to try to, focus on other material throughout the year that's more important that you have to remember versus something like this you can kind of reason out. So here's our example. It says most chromium atoms are stable, but Cr51 is an unstable isotope. with a half-life of 28 days. So T is referring to the half-life of 28 days, okay? So it says, what fraction of a sample of chromium-51 will remain after 168 days? So no matter what type of problem you're asked, you really need to start by figuring out how many half-lives you've undergone. So they'll either give you a total number of days, or they could kind of give you, hey, the starting amount and then the ending amount. You can kind of figure out how many half-lives from that. So we'll see that as we go along, okay, or as you get into some practice with it. So here they give us the total amount of days, which is 168. And we already know the half-life. So the half-life is 28 days. Okay? So all you're going to want to do is take your total number of days divided by the half-life time of one half-life, and then you'll figure out how many half-lives you have. So in this case, when you take 168 and divide by 28, you get 6 half-lives. Okay? So that means your sample has been cut in half 6 times. So if you're trying to figure out how much will remain after, so this is just, okay, what fraction? You can either put it in a decimal or fraction form. So there's kind of a couple ways you can do it. You could take, if you want to do a decimal or a percentage, you could kind of just take 100 and start dividing it by 2, okay, until you've divided it by 2 6 times. So this would be 12.5 divided by 2. That's going to be 6.125. This should be 6.25. divided by 2, so that's 1, 2, 3, 4, 5 times that I've divided by 2, and then this is going to be 3.125. Okay, 1, 2, 3, 4, 5, and then we got to divide it by 6 again. All right, I'm sorry, divided by 2 for a total of 6 half-lives. So your final would be 1.56%. If you started with 100%. Okay, so that's one way you could put it. But guys, you can also write it as a fraction. So that's one way. That's kind of like the straightforward way. Just kind of divide by 2, because that's what a half-life is you're cutting it in half. That's one way. Okay. Another way that you can do it is you can kind of make a fraction. So we can put it as 1 over 2 raised to the n power, where n equals the number of half-lives. All right? So whichever method that works best for you that you can remember, go with that. Okay? Find the one that you're most comfortable with. So in this case, it'd be 1 over 2 raised to the 6th power, which when you raise 2 to the 6th power, you get 1 over 64. Well, if you were to take 1 divided by 64, guys, you would get that same percentage that we had before. Now, if you took 1 divided by 64, it's going to give you like 0.0156. Okay, and just remember, hey, this is a percentage versus a fraction, so to really get this to be a true fraction, you would have to divide this by 100. Okay, so you can either put it in percentage form or you can put it in a fractional form. They really mean the same thing. Okay, so that's one way. Again, it starts with figuring out how many half-lives you have or you've undergone. That's the key. Okay, there we can figure everything else out from there. So I would encourage you guys to try to do this next one on your own. So if we're going to talk about it, now we have a starting amount. So we already know that 168 days equals 6 half-lives, because that was what we had in the problem before. So we want to figure out what percentage is left, okay, or how many net percentage, how many grams are left after 6 half-lives. So we can just take this and multiply it by our fraction. Okay, so we have 52 grams, and we can multiply it by 1 over 2 to the n, which is again one of the ways that we did it up above. So if we took 52 grams and we multiplied it by the fraction, which again, when you plug in 6 for n, you get 64. And when you do this math, you should end up with 0.8125 grams. Okay. Now, if you are good at remembering fractions, great. And that's something you want to go with. Otherwise, guys, you know it's 6 half-lives, so take that 52 and just start dividing it by 2 a total of 6 times. So 52 becomes 26, and that's 1 half-life. Divide by 2 again, which would be my 2nd half-life. That's going to take me down to 13. Divide by 2, there's my 3rd half-life. 6.5 divided by 2. All right, keep going. And then divide this by 2 again, because that's my 5th half-life. Then it's going to be 1.625 divided by 2 again. There's my 6th half-life. So now I end up with my 0.8125 grams. Okay, so that's kind of the other way that you could do it. So that's kind of the more straightforward approach of just kind of reasoning out, hey, half-life, I'm just cutting it down. But again, they both start with figuring out how many half-lives you've undergone. Okay. Now, number 6 is kind of doing the opposite way of where, okay, this is how much remains, but how much did you start with, okay? So now we're going to kind of reverse that process. So we know how much we're ending up with. Again, still 168 days, so we know that it's 6 half-lives, okay? So we're going to do kind of the opposite way. Well, if you think about the fraction method, like I had up in the problem before, all right, 0.75 milligrams is what I'm starting with. Well, do I want to multiply by a fraction here? No, because I'm trying to figure out how much it was at the beginning. So in this case, guys, I'm just going to multiply by 2 raised to my nth power. Okay, and again, the nth power is your number of half-lives. So 0.75 milligrams multiplied by 2 raised to the 6th power, which is going to be 0.75 times 64. It's the opposite of the fraction we had before. And that's going to give you 48 milligrams. Okay? Or, again, if this way is confusing to you guys, ignore it. Follow the other way. Just start taking your amount that you have. In this case, we're going to multiply by 2 instead of divide by 2. So, because we want to get to the original amount, that's been how much did we have before we underwent decay. So this is going to be my first one, and that's going to be 1.5. Let's multiply it by 2 again, because again, we underwent 6 half-lives, so we need to multiply it 6 times. So that's going to give me 3 times 2 again is my third one, so that's going to give me 6 times 2 again, that's my fourth, and then that's going to give me 12, multiplied by 2 again, that's my fifth, that's going to give me 24, multiplied by 2 again, there's my sixth, so in the end, it's still that 48 milligrams. Either way you do it, it's going to be the same, okay? So, other question you could see potentially on the Regents is they could give you a graph, okay? So this is just kind of explaining when graphing half-life and steps. Guys, just keep it simple. Look at your graph. It says, what's the half-life of substance illustrated above? So look and see, where did you start? Okay, at time 0, we had 50 grams. Okay, well, if we wanted to figure out 1 half-life, divide this by 2, how many grams would be left? 25 grams. So now I'm going to go on my graph to where 25 grams would be. That's right around here. Oh, look, there happens to be a dot there. So that would be my half-life. Now figure out what the time would be. Okay, that's about 25 days. It's not a 2, that's supposed to be an about sign. Okay, typically on the Regents, they're going to give you a graph that has more grid lines than this, so it's not really left up to estimation as much. So just be aware, but if they give you this is something I've seen, just you figure out the starting amount, divide it by 2 to figure that out, and then go from there to kind of reason it out. So again, half-life, guys, my hope is that it's a review. If you have questions, or as you have questions when you're doing practice, just call me over, and we can kind of talk through that. But just reason it out. That's the big thing. My big MO is to try to get you guys to think through its half-life, so you're either dividing by 2 or multiplying by 2. Start with figuring out your number of half-lives first. Until next time, I'll see you later.